Okay, let's do the dang thing, shall we? Hi, everybody. So today I'm going to be working on my website. It's been a long time coming. I badly need one, and it's kind of sparse. I've got my resume up here, which is nice. I'm happy with how that kind of came out. Got companies I have worked for, certain projects that I've referenced with links and everything, so I'm happy with that. But the portfolio page is not, in the sense that it doesn't exist. So the way that this website's set up is that it's hosted on Netlify, and it's built using the Zola static site generator, which is a Rust project, which is sort of similar to Jekyll, Hugo, things like that. And I am not very good at web stuff, so I'm just going to work on this and also take questions and stuff. You can find my website in its current state at aweigel.com, and you can take a look at the resume. You can take a look at the About Me section, which I think has something. Nope, not anything interesting. And as I kind of upload projects, I hope that you will have some questions about career stuff, project stuff, whatever you find to be interesting while I kind of plug away at this thing that I'm not really very confident in. And also, you can make fun of me. So that's the plan. All right, so step one, I've got all of these very nice photos of these PCBs that I've worked on in the past. All right, I've uploaded these all to the server that is doing the dev hosting for the website. So the next step is to kind of just display them all. So let's go ahead and do that. Where does this actually live again? Content, I think. Yeah. Okay. So one of the really nice things about Zola is that it can do this. It just does a live reload. Whenever you make a change to one of the files that it's watching, it will do a live reload for you. And the reason this is weirdly zoomed in is because I was trying to figure out how to do this in CSS. So the images that a friend of mine took for me are great, but they have a lot of white space. Oops, sorry. Still getting used to the mic. They have a lot of white space around them, so I was trying to figure out how to, in CSS, kind of like zoom in. And it turns out you can do that, but you're still serving the whole, 20 megabyte image. So instead, I had my lovely girlfriend go ahead and edit those down so that they're not quite so ginormous. And that's what we have here. So let's just kind of... You know what? These need better names. So let's go do that. Static, image, portfolio, small. Okay, so this is 7627. So this is the BB425 radio, which honestly is not a very good... It's a board that I was worked with and worked on and worked near, but I didn't design it. So it's maybe not the best thing to have in my portfolio, but I'll kind of tell the story of it in the text under the image once I get that working. Okay, and then we're gonna have this one, which is 36. So this radio, this is a radio. It's a UHF radio that was designed by a contractor. I kind of spec'd it out. This was when I was at Planetary Resources, acting as the lead RF communications engineer there. That company, for those of you who are not familiar, the goal was to mine asteroids for precious metals and water and other resources. That company is dead. They got bought by some sort of Bitcoin conglomerate, but the only reason that happened was, billionaire solidarity. All right, so that's what this is. This is 7636. So this is the down converter. So this is a down converter that I designed for a different radio that I worked on, but basically the goal was to extend that radio so that it could support the 2100 megahertz band for receive. That's a pretty common band for CubeSats and stuff. The power target for this is under 100 milliwatts, and it did actually work, which is nice. That right there is a frequency synthesizer chip. There's a mixer. Actually, I think that might be the... No, that's the mixer. And yeah, it's just a nice little up converter thing. These two are LNAs to get sufficient gain. And then that's the MSP 430, which is used to configure the frequency synthesizer. These chips were used because they use FRAM memory or FERAM memory, which is very radiation tolerant and also draws very low power. So they're good choices for satellites, small satellites in particular. Wow, I see we have 7 whole viewers. If you're interested in anything that I talk about, please let me know. And thank you for stopping by, regardless of whether you choose to chime in or not. I do appreciate that. All right, so let's see what the next one is. One would think that someone who was prepared for streaming would have figured out what his file names were beforehand, but no, not this guy. Okay, so this is the flight configuration of my Elysium VHF UHF radio. I'm actually really proud of this design. This is a CubeSat radio, and the goal for this thing was essentially very power efficient communication. And to that end, it's capable of 25 milliwatt idle receive power and 50% efficiency on transmit up to 5 watts. Both of which are basically, this is, the receiver in particular is an order of magnitude lower power than anything else that I've seen before or since. And I'm really happy with this project and how it came together. All right, so we're gonna go ahead and rename that. That's Elysium RX because it is, this is the receive side. The transmit's on the other side to provide isolation. Because on a board this small, it's really easy to get crosstalk between your TX and RX, and the easiest way to get away from that is to just have them on opposite sides of the board. Okay, what's our next contestant? (7663) is what? Okay, so it's the Elysium Prototype TX. 663. Elysium Proto TX. Okay, so this is the prototype of that Elysium radio. This is the transmit side. That you can see there, that's a Class C power amplifier, and it basically can achieve 50% efficiency as long as you have a constant peak to average power ratio. So it works really well for frequency modulation, like frequency shift keying, but it's not good for things like certain kinds of phase shift, and certainly amplitude shift keying would be terrible on that. It adds a lot of distortion to the more analog modes of transmission, but for something that's just, simple frequency shift, it's perfectly functional, and it's very efficient. Okay, next. So this is actually the first PCB I ever designed, or even contributed to, or anything like that. It doesn't do anything, really. But it was designed with a friend of mine named Katie in college. And what it basically is intended to do is, that's an MSP430. There's a lot of those. Or no, that's an MSP430. That's an op amp. And the idea was that you had this capacitive sensing pad. It got amplified by the op amp, and then it went into the ADC on the MSP, and with that you drove the 7-segment display. So when you touched it, it was supposed to change the 7-segment display, and it did do that, kind of. Looking at this now, there's a lot of things obviously that are pretty bad. The soldering job on these resistors is terrible. There's like no solder here, tons of solder here, cold joints, all sorts of terrible things. It was also the first time I'd soldered anything. And you can see these ridiculously hair-thin traces for absolutely no reason. It's just nonsense. But, this is how you learn. You do things that are not 100% optimal, and then later you do other things that are more optimal. All right, what's next? Ooh, so this one's fun. This is a pair, or it's the same converter board but populated differently. It's a converter board. It's a PFET driver for a GaN FET. So GaN FETs, gallium nitride is GaN, G-A-N. And GaN FETs are really interesting for a lot of different reasons. They can be very efficient. They have low switching losses. They, in theory, have 0 reverse recovery losses, a bunch of other weird stuff about them. But the main point of interest is that, in my context, is that they are extremely radiation tolerant. Instead of having, gate ruptures and total ionizing dose problems that weaken the crystal structure of your silicon, gallium nitride is much more resistant. Gallium arsenide also, but to a lesser degree. The thing about GaN FETs, though, is that for a long time they were only available in depletion mode, which doesn't work really well for like power switch type applications. So the new innovation is enhancement mode GaN FETs, or eGaN FETs. And so those are great, but the problem is that they're only NFETs. I said PFET controller. That's wrong. NFET controller. GaN FETs are eGaN FETs are only NFETs, and oftentimes you need to do high side switching. So the goal of this board is to do that. It's done with entirely discrete components. Ignore that. And it's specifically, these are BJTs, bipolar junction transistors, instead of FETs, because BJTs under radiation dosing, FETs tend to fail catastrophically. You can get something called a single event gate rupture, where a high energy particle will blow a hole straight through the gate oxide and just short the FET completely and destroy it. You can get other kinds of damage where, like, at a certain point, like, it works fine and then it just stops. BJTs, on the other hand, that isn't how it works. Because of the way that they're constructed internally, they just get worse, so they switch less, but they don't catastrophically fail. So oftentimes they're a better design choice for radiation for, CubeSats and other types of satellites. And obviously there are other ways to do this, right? NASA is probably not doing a ton of BJT discrete design, but they have a lot of money, and I didn't, and still don't. So this is a good low-cost way to get some amount of radiation tolerance. So this does everything. It has like an oscillator and a whole bunch of stuff. I think the intent for this was to be a charge pump controller. But anyway, the point is, that's what it's for, is it controls a GaN FET. And then the loading option is, there's this GaN FET, which is from a particular company. Can't remember their name. And then there's another one that's on the back side, which is a much smaller package. And I wanted to have the option to load for both. So we've got that set up. And that's why they're loaded differently. This is a really cool project. Unfortunately, my space company kind of fell apart before I really got to test it more than just the basics, but it looks really cool. I like how it looks in the pictures. It's got all this discrete circuitry. It was a good project to like flex my analog chops. I did a lot of simulations for this. I still have all the SPICE files and stuff somewhere. I'm sure I could find it if that was interesting to folks. I hope that some of this is interesting to folks. I mean, I put a lot of years of my life into some of these projects. I had a lot of fun doing most of them and not all of them. But yeah, they're, I hope, interesting to some of you. And if you have any questions, please let me know, and I'll do my best to answer them or just kind of talk about them. And it doesn't just have to be like really crunchy technical stuff, right? You can be, how did I get into it, or how should you get into it, or questions about how to make a career in these things, or what it's like to work in the space industry. Whatever you want to know about. The goal is to make this relatively boring and pedestrian task of updating my website be somewhat interesting by having folks, chime in and ask questions. So if something comes up, let me know. Okay, here we go. So this is Glasgow Rev B. I believe, actually, let's check. Crowd supply. So Glasgow is, or was, 43 hours left. Okay, so go get yours. So Glasgow is basically a multi-tool for electronics. The idea is that you have, your FTDI cable and your Xilinx programming pod and your logic analyzer and blah, 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 blah. And so Glasgow was designed to replace all of those. It's a very configurable device. It's built around an FPGA, an ICE40 specifically. It has protection on the I/O ports, so you basically can't blow it up. It can interface with anything from 1.2 to 5 volts, or maybe even lower than 1.2. I contributed to some of the early work, so revisions A and B, I would say, kind of have my thumbprint on them. I basically dropped off the project after that, but you can get the current revision, which is Rev C2, on Crowd Supply right now for the next 43 hours. And I would highly recommend that you at least consider it. It is a little bit expensive at $139, but given what it will kind of replace, I think it's probably worth that. Anyway, so yeah, that's this project. And we'll just go ahead and rename this. All right, we're getting to the end there. We got 3 left from this sort of batch of images. I do have some more stuff that I might add later, but this is certainly enough to be going on with. Oh, this is a secret project. Well, anyone who's watching or who watches the VOD can probably figure out what that is. This is a project I've been working on. It's a flash cart for a retro game system. It's not really a secret. The reason I don't talk about it is because the more I talk about a project that's not finished, the less likely I am to actually finish it. But I've been working on this with the help of some other folks for quite a long time now, and I'm really hoping to get it out the door in the first half of this year. And I'm getting close. But anyway, that's what this is. I don't really have a lot to say about it right now, because it's still kind of in media res. Is that how you say that? I have no idea. But yeah, again, if you have questions about it, it's not really a secret project, so I'll be happy to answer them. This is some automated test equipment that I designed for the CubeSat that I was working on at Planetary Resources, which, by the way, if you want to see something funny, I'm not going to pull it up, but there's a video of the orbital Antares explosion, which is what happened to the CubeSat that this was designed for, is it was on board that rocket when it exploded. Which, mixed feelings, but if you gotta go out, it was a pretty good explosion. If somebody wants to pull it up on YouTube, I will happily, show it, but I don't want to dig around on YouTube for it right now. So anyway, this is the ATE board, and basically the CubeSat avionics were like a stack of PC-104 form factor boards with these these non-standard Samtec connectors used to route signals between them. And the idea of this board is that it could play the role of any or all of those boards. So if I needed to test one board in the stack, I could mock all the other boards using this board. This project sucked to work on. It's not the technical side so much as it is that everyone had different requirements, and they basically couldn't be unified, and then I delivered a product that nobody was happy with, basically, at the end of the day. Also, this is where I learned about MOSFET body diodes, because these are supposed to be solid-state relays, but it turns out when you have body diodes, that doesn't work, and they all leak all over each other. And so we replaced them with these tiny boards built of physical relays, which don't have body diodes, obviously. Shout outs to my old roommate Kevin Baker for building those boards. He did a great job. And we fixed this, obviously, for the next revision. It does look really cool, though, right? Like, it's got all this stuff. It's got, 9 or 8 USB ports and Ethernet and blah, 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 blah. So it's pretty cool. It makes a good picture. It makes a good story. This is what I do when I talk about, like, a time that I failed or a time that I struggled in the workplace. When people are interviewing you for a job, they always want to hear about that kind of stuff. And this is usually the project I talk about for that. This one doesn't have a pithy name. It was the 633 board because that was the part number. And it also kind of alliterated because the satellite was A3 and it's GSE and ATE. So it's the A3 GSE 633 ATE B board. Which is a terrible name, but, we were under a lot of stress. Okay. All right. Last, possibly least, I have no idea what it is. I've lost all track of time and space. What do we got? Okay, so this is the low noise amplifier for the Elysium radio. So the Elysium, like I talked about, had a really low power consumption. Tell us all your secrets. Hey, cuz. I'll tell you anything you want to know. What do you want to know? Right, so the Elysium had a very low power consumption, which was great, but it kind of came at the expense of noise figure a little bit because the receiver IC was highly integrated. Means there's not a lot of room for a nice isolated low noise amplifier. So we had this off-board LNA, which was kind of powered by a bias T that was a load option on the Elysium. So this inductor here injects DC power, and then it goes in here and powers the amplifier. So this is just a strap-on board. You can kind of run a SMA through line, and it drops the noise figure significantly just because of how noise cascades work, and it only increased the power consumption. My target was another 25 milliwatts, but I ended up at like 10 maybe. Honestly, you could run this and the Elysium, and most of the time it would still stay under that 25 milliwatt target, which again, I'm really proud of this design. The reason for this big long snaky trace is, first of all, this board's coplanar waveguide because it's basically impossible to get a good impedance match on something this thick if you try to do microstrip. So it's coplanar waveguide. The center is the conductor, and then the exterior is ground. And the reason that the traces are exposed and it snakes like this is because, frankly, I was never able to get the simulation of this LNA to match what the vendor specs said it should be. And so I did my own matching network based on the simulations that I had, but I left all this exposed stuff and this extra trace length so that I could tune it pretty much arbitrarily to try to get an actually good match. And fortunately, my design worked fine in the first place, and so it could have been half the size, but it's already a really small board. You lose sight of it with these pictures because they're so zoomed in, but these boards are all tiny. Actually, I think I have one of these. I'm just gonna grab one from a box right over here. Give me 1 second. Oh, hey, I've got a bunch of stuff in here. All right, that's great. Okay, so we'll start with what's pulled up right now. Annoying Sidekick, thank you so much for subscribing for 16 months. My number one subscriber. Okay, so yeah, that's the picture, right? Look how big that is. And then this is the board. It's absolutely minuscule. I'm going to try to get an okay shot of it. Esden, hi, thanks for stopping by. You missed me talking about Glasgow. It's so small. Anyway, I did my best to shill Glasgow for you, so yeah. Esden is the proprietor, founder of 1Bit Squared, which is like a maker-focused hardware manufacturer and vendor, and they're running the Glasgow crowd supply campaign. Bro, you need a separate cam scene just to show off your hardware. Yeah, that's honestly why I don't do more like live electronics stuff, is I just don't have another camera hooked up that I could like show, because my soldering bench is right out of frame, just to the right there. I just don't really have a good way to show it. Okay, so where's this one? Sweet, we all thank you for the hard work and shilling. Thanks, I really appreciate, by the way, I don't know if you heard me say this, but I really appreciate that you guys left my name on the PCB, because I really don't feel like I deserve it. I dropped out so early in that project, but I appreciate that, thank you. Okay, yeah, so this is that. Again, just so small. Look at compared to my head. It's like an inch square, or 2 inches maybe. So that's this is the receive side that's shown there, and then this is the transmit side. So these nice little tiny boards. The reason this one, by the way, has Sharpie on it, this is what's called a solder sample. You are part of the story. You deserve your place on there. Well, thanks. I appreciate that. I'm glad you feel that way. So yeah, this has Sharpie on it because it's what's called a solder sample. It's basically there to let your manufacturer figure out their process and dial in the process parameters without having to burn a good board. Oftentimes they secretly work, and they just write on one of them like, oh, this one's broken, just because they didn't actually have any failures, but also, this is what a panel of those Elysium boards looks like. I think I got like 50 of them, because it's like the marginal cost, all of the cost in these PCBs, at least, not all PCBs, but those, is in setting up and running the process in the first place. And the marginal cost on top of that, if you want 50 versus 5, is pennies. Not pennies, but it's negligible. So I ended up with a whole panel of those boards. Same for these. I've got this whole bag of the LNAs, and I'm never going to do anything with any of them, which is a little bit sad. But, you move on from your things as life changes and circumstances change. The other thing I can show you, yeah, here we go, is the stencils. So this is a stainless steel laser cut stencil. Can you actually see the holes in these? $300 for 5 units, $330 for 50. Yep, exactly. So this is a stainless steel soldering stencil. And what you do is you align it with the pads. So this one, let me pull up the right board here. Okay, so this one matches that. Again, I still have no idea how much you can see. But it has the same openings that all of these pads where the solder is go. And so you get solder paste, which is basically like little balls of solder embedded in a flux material. And you just squeegee it across the stencil, and it deposits a uniform thickness of solder across all of those pads. And then you place the components on top of that solder paste and just bake it, and the solder melts and the joints form. So this is how all automated assembly goes. But if you're doing like densely populated surface mount boards, you want to use this workflow. It's way, way, way better than trying to do everything by hand. I actually have a toaster oven, again, kind of just off frame for doing this. You don't want to mix it with your eating oven. Don't do that. But it's really easy. You just pop it in the toaster oven at 450 and go to town. Uh, so yeah, I would highly recommend everyone get into that. I got that one from a company called Osh Stencils, but a lot of board houses in the kind of maker focused community will do stencils for you as well. And it's really good when you want to build some for prototypes. You don't want to pay for assembly. These boards were hand assembled. You can tell because of how janky they are. And it's just a lot easier if you have a stencil available. So that's pretty cool. I keep them just because I think they look cool, and I might want to assemble another board someday. Here's the Rev B Glasgow again, by the way, Esden. That reminds me, I probably have to get a Vapor Phase reflow for the upcoming project. Too many BGAs for reflow oven comfort. I would love to work with Vapor Phase. It seems really cool. The Galden stuff is really awesome. So what we're talking about, Vapor Phase reflow. So what I described is an oven, right? And you can have a couple different styles of ovens. I have a convection oven, there's IR, things like that. But an alternative is, instead of putting it in an oven, you do vapor phase reflow. So there's this material called Galden that you can tune the boiling point of. Thank you. I had a friend take it for me. She does it professionally. Her name's Janae. If you need product photos taken, I will happily pass her number along. Anyway, you can tune the boiling point of this liquid. It's inert. It doesn't affect you or hurt anybody. But basically, you can tune the boiling point. So you can change it so that it boils at the solder's melting point, or whatever temperature you want to bring the board up to. Then you heat the liquid. It boils. The vapor comes up, but then it hits the board, which is cold, and it condenses. Can you share it with me? I was looking for a photo like this for the Glasgow update the other week. Yes, I will. Please DM me on Twitter or I will forget. But yes, I will happily do that. Yeah, so the vapor comes up, it hits the board, which is cold, and then it condenses on the board, and just because of the physics of it, that brings the board up to temperature. But it does it, in a really, all-inclusive way. It transfers a lot of heat very quickly, but also in a very controlled way, because just purely by the physics of it, you cannot overcook the board. And it's extremely safe, it's extremely effective, it gets really even heat distribution. The only thing is that Galden is crazy expensive. But, if you're someone like Esden, who has an actual company, it can be totally worth it. And you can reuse it mostly. Like I said, it's inert. It doesn't really react with stuff. And it's not very dangerous unless you bake it completely dry, which you'd have to really try. Yeah, it condenses on the cold places, so the joints, and it gets into every nook and cranny. It brings things up to a really uniform temperature. It's great. It's really cool stuff. I would love to work with it someday. Have not really had an opportunity to do so, unfortunately. Where was I? Okay, so I think this is my last picture from this set. Okay, oops. Let me see what else I've got, because so these pictures are specifically of assembled boards that I thought were interesting of pictures. It's very pricey, as you say, and it's the liquid that's the problem, not the machine itself, really. Yeah, exactly. The machine is very simple. You basically just heat liquid. Can you set up custom point redemption options, please? All right. Diana, will you make sure that I actually do that so that Johnny will stop hounding me? I mean, Frank Willard will stop hounding me. Check out DJ Frank Willard's stream, by the way. He's my cousin, and he does a really cool DJ stream very regularly. He has an actual stream schedule and things, which I will never be disciplined enough to do. Let's see, what do we got in here? So I have some photos that are just boards for a bunch of different stuff. Oh, okay, so here's, this is a Beaglebone cape that I made. Frank, half wrong. I can confirm it's cool. Yeah, right, it is. It's very cool. Welcome, by the way, to everyone who's come by. I really appreciate you stopping by and listening to me just kind of talk about stuff. What was I saying? Right, so this is a Beaglebone cape. So the Beaglebone is a Linux single board computer. It's kind of like the Raspberry Pi, which you might have heard of. And this is an add-on board for it because I think I did this because I needed a portfolio project because I was having a hard time getting a job after my company Adamant Aerospace collapsed. But so the interesting thing about this board, I would not recommend this. It's a bad design, but the interesting thing is this is a USB device controller, and it's 2 layers, and it's a little bit complicated, but differential signaling on a 2-layer board can be really tricky if you need to maintain a particular impedance, because the distance between the top and the bottom layer is so far and you can't adjust it. So what I did here is I just made the board super duper thin, and actually I have some, I think. Let me just grab one. Because you can see when I pull one out that they just kind of wobble, wobble, wobble. I hope some people will come from the 1-Bit Square Discord too and ask your stream there. Oh, thank you. I really appreciate that. Right, so this is nice and thin compared to... Let me grab another board so you can compare. Okay, so you can see the difference in the thickness. Right? I don't know if you can or not. I'm doing my best vis-a-vis cameras. Let's move it over so it's shown behind the white wall. Let's see here. Is that better? Okay, whatever. It's thin. And I did that so that I could hit the target impedance, and it did work, but the problem is that the board will just flex, right? Like I can just bend it in half, and it's a terrible structural problem, especially with all of these connectors. The force to separate them is already really high, and when the board feels like you're going to snap it in half because it's so thin, it's a bad design. What you do instead, by the way, is you do a so you do coplanar waveguide, which I was talking about before in the context of this LNA. Right? So this is the same thing except you do a coplanar waveguide. Thank you. Tier 1 for 6 months. Wow, that's really generous of you for the hardware cam setup. Okay, I'll get one. It's a good idea. I should get like a macro lens and stuff. Is it possible to get thinner pins for lower insertion force? I never looked into that. Yes, but it wouldn't fit well into the BeagleBone receptacles. I don't get to change those, right? Because that's just a commodity product. Anyway, so yeah, coplanar waveguide. This is single-ended coplanar waveguide, but you can do a grounded differential coplanar waveguide, and then you can have your nice thick board and still hit your impedance targets. The only problem is that at the time I didn't know where I could find a calculator that would do that for me. Let me pull it up. So KiCad actually ships with one, which I didn't know. KiCad, for those of you who aren't necessarily in the hardware space, is the program, the open source program that we use to lay out a lot of these circuit boards. KiCad, okay. So KiCad ships with a bunch of utilities that they like don't tell you about for some reason. And one of them, where is it? One of them is called like T-Line or something like that, and it will calculate these traces that you need for a differential coplanar waveguide. Where is that? KiCad two-step. Alright, I guess it doesn't matter. But yeah, you can calculate them so you can have nice thick boards and you can still meet your impedance targets. And things are just generally a lot better. What else do I have in here? Okay, so this is the bare board version of this larger board here. I like these diamonds here are what's called thieving, copper thieving. And they do this so that you don't actually need copper here, right? This isn't connected to anything. PCB_calculator. Thank you. So this copper isn't actually connected to anything. But what it's there for is to keep the mass of that layer relatively constant across the board. Because if you have a ton of copper over here and no copper over here, then when you heat it up and cool it down, the copper heats and cools faster than the insulator material does, and so the board will warp because the copper dimensions will change and they won't change uniformly across the length. And so it will apply a bending moment and bend the board basically, or twist it, or just distort it generally. So you add useless copper. I mean, the fab does this, you don't do it yourself, but useless copper is added to keep that mass the same so that you don't get those distortions. Another interesting thing here is you can see these kind of lighter areas, and that is an isolation cutout. So everywhere else there's a fill of ground copper on the second layer, just for a bunch of different reasons. That's just generally good practice. But the spacecraft, which is supposed to go in this center spot here, needed to be isolated from the test equipment that we were driving it with, and so every single one of these interface ports is isolated. And so this cutout is the isolation barrier. You leave a space of no copper so that you have actual separation between, this island and then these over here. Is this your prototype right here? So this is actually the production version. This is a board that I worked on when I was at Planetary Resources, the asteroid mining company. Now defunct, rest in peace. So this is the board that I worked on when I was there. It's the same as this picture right here. It's just that it doesn't have all the stuff on it, right? But I did do all the design. It was a terrible project. All the requirements were conflicting. No one was happy with the results. I talk about this a lot when I have to talk about like a failure or a difficult project that I've worked on, because it was a nightmare. And then let's see here. So here's the Elysium hooked up to its air conditioner. This is just a fan because you need to heat sink that big power amplifier. Okay, so I said it's 50% efficient and it goes up to 5 watts. That means that if you run it flat out, it dissipates 5 watts of heat in like not a lot of space, like 8 millimeters square, something like that. So you need something that will cool it off and sink the heat away. And so I have this big fan strapped to the bottom of it. Except that actually it didn't end up needing that because I don't know if anyone but me will find this as funny as I do. But so when you put holes in the board underneath a pad, right? The holes are called vias. When you put them underneath a pad, you want to plate over the hole so that solder doesn't get sucked down into the hole. You want the solder to connect the board to the pad. So what you do is you put an epoxy, right, like basically a glue, into those holes before you plate the copper onto the board so that it just covers over and then you have a nice even pad. What these guys did instead, these were fabbed by a company called Avahi Circuits, I believe. So what they did instead is they just kept plating with more and more copper until the via closed itself up from just pure copper plating, which is about the best thermal interface material that you can possibly get. So it turns out that this board didn't need any heat sinking at all. It would just happily dump all 5 watts into the board, and eventually the board would come up to temperature, but that would take hours. Normally you would have to pay so much extra for that it's not even funny. I think they honestly just screwed up. But if you took a bandsaw and cut through this thing right here, you would find these just solid cylinders of copper, which I find hilarious, but probably no one but me does. Let's see. Okay, so this is the prototype of that Elysium radio. It has these wings on it because these are rails, basically, that you use to move it around with automated equipment, or when you're assembling, it has these like dots on it, which you can use to find where the chips go with your vision system on your pick and place machine. So those are somewhat interesting. Let's see here. This is my quarter for scale picture of those 2 boards I showed you earlier. They're just so small. I'm still really proud of this design. Anyway. What do we got? Oh, okay. So you wanted to talk about prototypes. This is an extremely janky board. All right, so let me go through the story here. So, where is it? It was the first one we had. Yeah, so this board, the BB425, which, by the way, was designed by not Helen Mirren, Helen something, and Henry Hallam. No, not Henry Hallam. Matt something. Anyway, whatever. That company's dead too. But we had this board, but we had nothing to talk to it. So this board communicates over just like regular SPI interface, and we had nothing with which to communicate with it. So we hacked this thing together in like a day and a half. It's just a carrier card for this radio, and it has an MSP430 on the back. That's it. It was an incredible rush job. It's like on the cheapest, crappiest, like plastic PCB you could possibly buy. Yeah, this thing was awful, but it served its purpose. We needed something that we could test with, and we got it. This is slightly different, but yeah, so it's very similar in concept to this board, which is SCB for System Communications Bridge. Again, this is a carrier for a radio. This was on our first CubeSat, the ARKit 3, which was a 3U CubeSat that was basically designed to be a technology demonstrator. It's the one that blew up, by the way. If you want to Google that Orbital Antares rocket explosion, that is the fate of this board. It's a pretty good explosion. I recommend Googling it if you have some time. But anyway, so this is a carrier for a commercial off-the-shelf radio from a company called Microhard. This is another good like failure of a project discussion. So this radio had been tested by other CubeSats and found to work, and found that it drew about 5 watts of power when it was transmitting. That was the Microhard MHX 2400. By the time we came along, you couldn't buy the 2400. You had to buy the 2420. The 2420, spoiler alert, end of the story, draws 15 watts when you transmit. So we just tripled our power budget on our CubeSat that's like this big and has to run off solar panels. Not good. And the reason we didn't catch that, we ran a test. We were like, hey, we got a test. We got to make sure that this is, we have our numbers right. But the person who ran the test was an intern, and they tried to do low side sensing. So they sensed the current through the ground lead instead of the power lead, which would be fine, but you have to really nail down that you only have one ground connection. And he had a second ground connection that he didn't notice through the FTDI cable that was connected for communication. So, bada bing, bada boom, he measured 5 watts, which is what he expected to find, because we had papers and we had case reports that said, hey, it's 5 watts. No, it's 15 watts. And this right here basically doomed that mission. I said I had mixed feelings about it exploding, and one of the reasons is that we were all pretty confident it wasn't going to work. And the explosion plus our insurance bought us like 6 months to do a better job, right? To basically finish. The thing about this is we were what's called a secondary payload, which means we don't own the rocket, and we're also not the main, like the customer for the rocket. So that means that we are basically completely at the mercy of the rocket and the primary payload. And so if they say we're going to space today, we have to be ready to go to space. But neither the rocket nor the primary payload is ever ready on time, but neither of them wants to admit it, because if they admit it, they have to pay for it. And so they are engaged in this game of chicken about, oh, we're going to be ready. Are you going to be ready? Oh, no, we're going to be ready. Are you going to be ready? And meanwhile, we have to pretend like the obviously made up dates they're spouting mean anything. So this project was just a disaster from start to finish, but one of the big reasons for that is because we were under this incredible time pressure, but we also knew that it was fake. it's really hard to explain if you've never been in the situation how demoralizing it is to kill yourself to meet a fake deadline. Like, oh man, it was just horrible. I hated it. It was a terrible experience. It's honestly one of the big reasons why I'm not in the space industry right now, is because of that. Like, I don't really want to work at your NASA and your other like huge conglomerates, but if you don't, then you have to deal with this kind of thing. Or maybe not. I mean, Planet Labs did pretty well, and so on and so forth. So maybe that's just me being bitter because I had a bad experience once, but those feelings are real. Whether they are based in truth or not, the feeling is real. And so I'm not in the space industry anymore. Oh, okay. So here, this is my second ever PCB. This is a great PCB. I love this thing because everybody signed it. So I was an intern at a company called Andrews Space when I designed this. It's automated test equipment again for a PC-104 card that was again going to go in a CubeSat. There's lots of things wrong with this board. I could go through some of them if you want. The most notable is this switch footprint is hilariously incorrect. The switch is like 4 times wider than this. And so none of them fit, and I had to design like these weird adapter PCBs to make them fit. But when I left, everybody signed it, and they told me how happy they were to work with me. When I came to this company, I think they basically expected me to do nothing, like the other 2 interns did nothing. But I actually did stuff because the stuff was super interesting. I mean, it's a space company. You want me to just sit on my ass? So I did this board. I did a couple other boards while I was there, which unfortunately I didn't get to keep copies of. And so this is that solder sample that I was talking about before. It's a non-functional board. You can see they basically just took pliers and ripped a big chunk out of it up here. But everybody signed it when I left, and it's hanging on my wall today. It's really nice. It makes me happy every time I look at it. Do I have anything else to show you? I don't really think so. I have a bunch of product shots of a couple of different boards and things that I played with, but I think they're all basically the same. Oh, okay, so here's one. This one's kind of cool. Again, this is not a board that I designed. I spec'd it. So this is the antenna for the Arkyd 3 satellite. It's actually 2 antennas. We have a right-hand polarization antenna over here, and then we have a high gain left-hand polarization over here. This antenna was a bad idea, but it's a really good design. We worked with a company called Star H Corporation to get it built, and it's comically thick. I don't have an edge-on shot of it, but it's like, I don't know, a 1/4 inch thick PCB. And its design was basically to give us high gain for high data rates, and then also low gain for like reliable communication. But you can't really do low gain at S-band with a patch antenna. It doesn't really work. So the best we were ever able to get out of this is like a half sphere coverage, which is not good enough when you're an uncontrolled tumbling CubeSat. This is another reason why that mission was pretty much doomed from the get-go. But that being said, working with these guys was really good experience for me. I learned a lot about working with vendors. I learned a lot about antennas and testing of antennas in particular. They delivered so late, which is a learning experience when you work with vendors. Frequently, they do not deliver on time. Also, funny story, their board vendor built it upside down the first time. So the layer stack up is called out. You need this much spacing between these planes and so on and so forth. And they just swapped it. And so they spent like a week and a half in the lab. Like, why isn't this working? Our design, our simulations all say that it works, but it doesn't work. And then eventually they took a bandsaw and cut one in half. And they were like, oh, that's why it doesn't work. It's built upside down. So that was great. Do I have anything else to show you, or do I get back to just kind of fiddling with the CSS and stuff? I don't think so. I think that's basically it. This is what product shots taken by me look like, aka terrible. This is that GAN controller again. It's sitting on a Lego. I have no idea how to remove the Lego. Whatever. I want to say thanks to everyone who's here. I mean, I'm up to 10 viewers right now. That's great. that can't possibly all be people I know. So that's awesome. If you have any questions, if you want to talk about anything, you can see the website in its current form, by the way, at aweigel.com. My resume's on there if you wanted to ask any questions about like career stuff or whatever. But yeah, I really appreciate you stopping by and listening to me talk about all these old designs that I worked on and just kind of ramble and reminisce. It's been really fun. If you have any questions about anything, feel free to chime in. It doesn't have to be these boards specifically. It can be, anything else. But yeah, it really means a lot to me that y'all stopped by. All right. So I don't actually want these all to be on the same page. I would like to kind of paginate it, but I don't really remember how that works. You done? No, I'm not done, but I'm kind of done going through designs and like just going through the spiel of them all because I'm out of them. Basically, I'm out of designs. So what I'm going to do for the rest of this is just kind of like add some text to the website, tweak the layout, kind of go through stuff like that. Can I ask a non-related to your stream but tech question? Yeah, go for it. If I can help, I will. God, I'm so bad at just like web stuff. Oh, hey, Dub. Morning. Oh, geez, is it really? What time is it there? Okay, so that looks pretty reasonable. The BB425 honestly maybe doesn't even deserve to be on this page. I know what I'm going to do. I'm going to make like an ARKit 3 section. And then we can kind of go through all of the ARKit 3 boards. Oh, I changed the name of this one. Got to do that. Will you believe me if I say I just woke up? I mean, yeah. Isn't it like 5 there? You're like +8 from me, aren't you? Like 5 a.m. to be clear. Alright, so let's make like an Elysium section, which will have... Let's start with Elysium. RX. TX. Down converter. LNA. I'll do this in like order from oldest to newest. I think. So that means that, or going the other way, newest to oldest. I might talk about some other college-y stuff. Yeah, started doing a VGA breakout for practice and got quite into it. I don't know what to say about that. That's the most tedious thing. Why does OBS need access to your computer microphone in order to allow you to access to an audio source which is not your microphone? That is an interesting question. You're on a Mac, right? So the permissions thing might be a little bit weird there. But it honestly, the totally unhelpful answer is because somebody coded it that way. Which, yes, I'm aware, not useful. But I think in Windows, all audio sources are assumed to be microphones, unless otherwise sort of indicated. So that's my best guess, is that just like somebody didn't really think about it. I don't have a good answer for you, I'm afraid. No, that's Marcan that works on OBS, right? As then that's not you. You don't contribute to OBS and stuff, do you? But I think Marcan does. Is who I'm thinking of. Grinlord and then Glasgow. Marcan did a bunch, but I recently wrote some minor patches for V4L. And to my surprise, they were merged. It's probably not great about the like general Linuxy ecosystem that's surprising. Okay. I really should figure out how to do pagination, but I'm not going to bother right now. I know there's like nice built-in support for Zola to do that. OBS Linux support is a stepchild of the project, which is very sad. That is sad. I'm kind of surprised to hear that. OBS, the original OBS, had a very Linuxy vibe to it. OBS Studio, I guess, seems a little bit more... Is it sad if I say professional and therefore not like Linux? But yeah, that's kind of surprising to me to hear. The core devs keep saying we don't know anything about Linux. That seems like a problem that could be rectified by finding some more core devs who know something about Linux. But, you know, what do I know? I'm just a engineering manager now. Sag. What is Sag exactly? Is it like sad badge? I'm so old. Except you're older than me, so I guess I can't use that excuse. I knew that I was old a little while ago because I made a reference to InSync in the Digital Design Discord, and just nobody knew who that was, and I realized that I was just old bones. Yeah, but that would mean someone would have to plan and manage and hire. Seems hard. Yeah, I mean, I've been thinking about this a lot. This is kind of a tangent, but what does an open source project manager look like? Because every open source project I've ever been involved with desperately needed something that kind of slotted into that role, but I have absolutely no idea how to set that up in the context of an open source project. It seems like a recipe for tin pot dictators. A Weigel, what is a BGA breakout? So a BGA is ball grid array. It's a certain type of chip. I must have one in a picture somewhere. Where am I? Maybe I don't. Okay, I guess I don't. So, oh no, RuneLord has one. Oh, but that one's populated. Do I have an empty RuneLord picture? Nope. Alright, whatever. It's ball grid array. It's an array of balls. Shocking. Instead of the pins, right? So this here, if we look at the image and zoom in, so these are pins, right? But this chip has no obvious pins. And the reason for that is because it's a BGA. And instead of pins, there are solder balls that go under the package. And you just heat them up and they bond directly to the board. And you can fit a lot more pins in the same package area, basically. Because obviously, the edges start to get crowded very quickly. This thing has, 256 pins? So that's what a BGA is. And then a breakout is when you're routing a circuit board. Oh, good, that didn't come up on the shared monitor because it's client work. By the way, I'm available for hire if you have a PCB or software or FPGA project that you need help with. Look me up, sorry. Okay. Okay. So when you're routing a circuit board, you need to be able to get signals out without hitting other signals, basically. And so that's where you break the traces out from the array, right? And so you end up with something that looks kind of like this, where you have all these vias and you have all these traces, and it's so that you can get at the signals even on those inner balls, and route them out to other areas of the board. So breakout. That's what Dub was talking about. Did that make sense? That is what maintainer is supposed to mean, I think. They maintain, aka manage the project. But the hardest step for an open source project is to transition from a few enthusiasts coding stuff to we need an organization and a nonprofit and managers. You're available for hire, makes notes. I mean, that would be great. I would love to work with 1Bit or, you directly if that's what you're talking about. But yeah, just keep me in mind. Available for freelance work. Anyway. Yeah, you're absolutely right. And it's even worse because the skills you need to do the technical side are not the skills you need to do the people side. Often they are like antithetical, which is a little bit depressing, but it is what it is. And that transition is really difficult. I think there has to be something in between. There has to be a way to lay out a project such that you can smooth that transition. I think what Rust does, the Rust project, is really interesting. The way that they have like really codified procedures. I think they go maybe a little too far, or like you want to grow into that level of codification. But the other thing is having like a roadmap that is really detailed. Like when you say, okay, I need to do this, I think you need to write it down and put it on the issue tracker and say, look, this is exactly what needs to be done. Go into this file, add this functionality. It will interact with these systems in these ways, and then don't do it. Because as a technical person, once you figure it out, you want to do it, and you want to like make sure that what you think will work, and blah, blah, blah. And I think that having those sort of onboarding issues is really important. Yeah, I think documenting the roadmap projects took and share it with other projects. That is also something that would be really good. I think there was like a book a little while ago that kind of went through like a bunch of different really popular open source projects and how they got to where they are. I'm trying to remember what that's called. I think it might have been a little more technically focused though. It would be really cool to have like interviews with from the Rust community, like Grayson and Nico and some of those folks, and how they got to where they were going, and even Torvalds, right? Or Greg KH, Noah Hartman, whatever. The maintainer guy from the Linux kernel. I don't know, some other folks from some other projects. It would be really cool. KiCad, yeah. I mean, KiCad, they had Wayne, I think is the guy, and then there's all the CERN stuff. It would be really cool to have like interviews with those folks. Okay. Generating new project part of the brain needs to turn off. I've got enough on my plate. I can't go around trying to interview a bunch of people about projects. Oh, by the way, Esden, I caught your Q&A with White Quark in the 1Bit Squared Discord the other day. That was really cool. I didn't know that Crowd Supply did that. I thought it was really interesting. It answered actually a lot of questions that I had because I haven't been following the project that closely. All right, so this is the first PCB I ever worked on as part of a circuit design class for my degree. Crowd Supply is growing their social outreach. So how does... I've been thinking about this because one of the projects on this list is something that I kind of want to put on Crowd Supply. Has your experience working with them been positive? Have you found that you're in kind of an interesting situation because 1Bit already kind of knows how to do a lot of stuff, but do you feel like they would give beneficial like support to a project. Something that like, okay, let me give you a concrete example. I designed a shell, right, like a case for this thing because it's a flash cart. It goes in a console. It needs a shell. So I designed one, and I'm done some prototyping. I'm going to prototype it with my resin 3D printer and blah blah blah. But I would like to get it injection molded at like an injection molded prototyping place. Is Crowd Supply is introducing me to an injection molding supplier something Crowd Supply considers to be within their remit? They definitely would help with promotion, assets, and so on. They can also get you in touch with manufacturers. Okay, that would be great. That's really good to know. Like I said, I'm gonna try to get this thing out in the first half of this year, as long as nothing else terrible happens to me or my loved ones. But yeah, so I'm definitely gonna keep that in mind. I met a Crowd Supply person at the Open Source Hardware Summit in Denver a couple years back. You have to submit the campaign idea to them and get talking. Also, you can always ask me. Yeah, as soon as so I have one more major hardware subsystem to validate on the prototype, and once I've gotten that to the point that I know it works, then I'm gonna reach out to them. I'm gonna do another round for some of the DFM tweaks and things that I've run into, and just fix some bugs and things like that. And but during that, I'll be talking to Crowd Supply is kind of my goal. How long did it? Well, okay, again, kind of an interesting situation because Glasgow's been up for like 2 years. But how long do you think that process takes? Is it like a 6-month process, a 1-year process? I have like 4 submitted and pending campaigns with CS at the moment. Oh boy, that is a lot of work. Glasgow took much longer than others. Well, yeah, I mean, it's a fairly complex project, especially on the software side. Software is like simultaneously free and the most expensive thing in the world because of how long it takes to develop. When you know where you are going with the campaign promotion and how to describe it, it can go pretty fast. 2 weeks maybe. Okay, that is pretty fast. Frankly, I'm impressed by any company that can get anything done in 2 weeks. So that's perhaps one of the most encouraging things you could have said. By the way, thanks to everyone who's watching. I mean, don't feel like just because I'm talking to Esden and I'm talking to DJ Frank Willard and they happen to be people that I know to some extent, don't feel pushed out by that. I'd be happy to hear from anybody who's listening. You don't have to be technical. You don't have to, if there's anything that you want to hear me talk about or have a question about or just want to say hi, by all means, feel free. If you don't want to do that, that's also totally cool. Am I still in Portland? No, I was never in Portland. I'm in Seattle. Well, Redmond, just east of Seattle. I drove down for what was that? Was that the Foci folks put that together? But yeah, I drove down for that. Still close enough. Yeah, I mean, it's only a 3-hour drive. I used to do that drive twice a weekend, every weekend, for like 6 months. Okay, my cat has rolled over on my KVM, and I've lost all my USB, and now they're coming back. Okay, we're back. Yeah, I mean, once we can travel again, it is close enough. right, let's see how that looks. Yeah, that looks alright. I mean, this picture is kind of big, but, you know, whatever. Yeah, just checking. It is good to have a reasonable option for in-person when things go a bit back to normal-ish. Yeah. Sometime relatively soon. It seems like Washington has their shit mostly together as compared to some other states. But, you know, it's a logistics problem for sure. Can I just say, you know, I have absolutely no tolerance for like, oh, real programmer gatekeeping nonsense. Web stuff is so hard. Like it to the extent I have any like disdain for web programming stuff, it's the environment, not the people. The people who do web programming and are actually good at it, I have boundless respect for. I see it way too often like, oh, JavaScript, why don't you learn a real program? JavaScript is a real programming language, first of all. And even if it wasn't, like being able to just make anything is so impressive. And that's like, I don't know, it's such a rat's nest of an environment. I have nothing but respect for those folks. I absolutely drives me nuts when I see people looking down on web folks. Oh, hey, by the way, a recommendation for all of you who are enjoying this stream. Shirley Wu is someone who does data visualization. She does live streams, I think once a week. It used to be once a week anyway, where she'll take some data set and like visualize it and make pretty pictures in ways that are like really helpful to kind of show you the data in a way that will help you understand what it's actually saying. She's a great Twitch follow or Twitter follow. It's SXY Woo, I think, on Twitch. But yeah, she's really great. If you want to go follow her, you will not regret it. Free plug, unsolicited, but I really enjoy watching her work. The web stuff can be really hard. Knowing the API stuff and be able to work in that technological debt well is hard. Hats off to those that make it look easy. Absolutely. That's exactly what I'm saying. Oh, Esden, I forgot to ask. How did you come to know that I was streaming? Are you I think I only posted it in the digital design Discord. Um did somebody let you know, or how did this come to be? I did such a bad job promoting this, but I didn't really expect it to be terribly interesting. You posted a while ago that you are streaming. And I followed you and got a notification today. Oh, okay, cool. That's awesome. The system works. Well, a system works. Drive the necessary control signals over isolated communication interfaces. Although this board served its purpose, the process of design was very difficult with many different stakeholders, each with incompatible desires for the design. I think the first stream of yours I lurked into for a bit was the WoW one not so long ago, or maybe it was recording. Not sure. Yeah, that was just a couple days ago. Okay, it was last week. Whatever. God, time. What is time? Anyway, yeah, that was a lot of fun. I really enjoyed streaming some video games for a change. I basically dropped out of streaming for like a year because the world was on fire and also I was busy. But I'm really trying to get back into it. It's a lot of fun, and I forget that when I go a long time without doing it. And then it starts to be like a stress thing where I am worried that because I haven't streamed in so long, like it has to be some amazing, incredible event, which is not reasonable. And then I like get all up in my head about it. This is a problem that I have in a lot of areas of my life, and I'm constantly working on improving that loop. So streaming. So anyway, I'm gonna try and stream at least once a weekend for the next little while. We'll see how long I can maintain that. Yeah, it's like falling off a bike. You have to get right back on, otherwise feels. Yeah. You know what I compare it to is when I was a kid, I read a lot of books. I still do, but when I was a kid, I was reading like big, thick, like fantasy novels. And if something happened that disrupted me when I was in the middle of one, I almost always would just start over because I like couldn't pick it up in the middle and like get back into it. And I find myself tempted to do that in a lot of things. I was like, well, I could just blow away my Twitch account. Like, fool, you have 150 followers. Why would you do that? That would be insane. You're a Twitch affiliate for some reason. Like, that would be so dumb. That's what my brain wants to do. Is like, oh, you haven't looked at it for a while? Burn it to the ground. Like, no. I don't know how to say what I'm trying to say here. So what I'm trying to say, I'm just going to say it out loud, and then we'll see if I can figure out how to write it down. This board worked, right? I'm talking about this ATE board. It worked. It was really hard to design. There were a lot of people who cared a lot about it, but they all wanted different things, and the timeline was very compressed. And so the tensions were really high, and it was really difficult to come to a design that everyone agreed was acceptable. And this isn't the only time that something like that has come up in life, because of course not. That's how it goes. And so it is good that I had this experience so that I can kind of see the warning signs of that kind of an environment coming and try to get out ahead of it in a way that isn't quite so fraught. That's what I want to say. So how do I write that down? Each with strong opinions about... Each with strong opinions. The timeline was also very tight for the project, which further raised tensions. Restarting a game playthrough from midway. Yeah, exactly. Same basic principle. I really love, by the way, these games nowadays that have the like, hey, dummy, this is what you were doing feature, because like they've recognized that gamers are now 30. I'm so old. And that they have busy lives, and so they don't necessarily play 40 hours of Dragon Age in a week. From this project, I learned to see the signs of such tense situations coming. which allows me to anticipate them and get out ahead of any potential conflicts. Although it was a very unpleasant experience at the time, I use those skills regularly in my day-to-day work. So on balance, I'm glad I worked on this project. Alright, that's good enough. It's not great, but, you know, it'll do. I don't really know, like, what people would care about on a page like this. I kind of think they're just going to flick through the pretty pictures, but I don't know, maybe I'm underestimating folks. This seems like a good time again to say thanks everyone for stopping by. It really means a lot to me. Artist portfolio, yeah, exactly, right? That's kind of the goal. Is, hey, you might want to hire me. Look, I've done things. Like, yeah, that doesn't necessarily mean you can do my thing, but still, at least you've done things. The ability to deliver is sadly not evenly distributed. Anyway, like I was saying, I really appreciate everyone stopping by. It really means a lot to me that you take some time to just watch me do this. If you have any questions or if you want to, say hi or anything like that, I would love to hear from you. If not, that's also totally cool. And it still means a lot that you decided to take time out of your day to join me. Okay. I don't even know if this really belongs here. I think I'm just going to write the little blurb, but then not actually include it. I'll just comment it out. How do you do comments in Markdown? I guess you can just do HTML comments. Which was designed by, what were those people called? Bitbeam. Bitbeam. Helen Lurie, that's her name. A now defunct RF contracting, not really, RF product development company. According to my specifications as the lead RF communications engineer at Planetary Resources. This radio was targeted at the ARKID 6 CubeSat. Genius man, I have to be on my way. Night, chat. Thanks for stopping by, cuz. I appreciate it. Thanks for the sub. You the best. Have a good stream next couple days. Everyone, check out DJ Frank Willard if you're into EDM and, DJs and that kind of thing. He has an actual, stream schedule and a really professional setup. Also a lizard who's very cute. If you like lizards, which I do. Good vibes, good music, exactly. So check them out if that's your thing. This radio was targeted at the ARKID 6 CubeSat, which was intended as a demonstration of mid-wave infrared imaging technology for asteroid prospecting. Later. It was the low speed. What does TT and C stand for? I always say it and I never know what it means. Telemetry, tracking, and command, right? which was paired with a high-speed SDR-based, which served as a fail-safe communication method for the mission. It was paired with a high-speed SDR-based radio for payload data downlink. The BB425 would inspire some features of the Elysium radio later. In particular, the need for extremely low power consumption in the idle receive mode. The Elysium radio consumed an order of magnitude less power than the BB425 in that mode, 25 milliwatts as compared to 250 milliwatts. I feel a little bad writing about this thing because I don't know. It's a good design. Don't get me wrong. They did a good job, but I don't know. I like my design better, I guess. It wasn't bad. And to be fair, a lot of the things that are kind of questionable decisions we forced on them, so it's not really their fault. I love these edge mount connectors, these drop-in edge mount connectors, by the way. They're such nice, like really mechanically robust SMA connectors. Like you can put so much torque on this without like shearing something off the board. And they're nice and flat so you can pick and place them easily. Okay, I need to go, but I left you some messages on Twitter DM. Okay, great. Yeah, I'll check that when I'm done streaming, and I'll be sure to hand you off that Glasgow picture and address whatever other questions and stuff. Cool. Thanks, Esden. I really appreciate you stopping by and also advertising me to the 1-Bit Discord, which I should join. Have a good night. Okay, what's next? Down converter. I think I need to do these in a... Yeah, okay, so I do have them in a nice order. Looking forward to your future streams. Thank you, that means a lot to me. Where am I? Right, Elysium. I want these to be side by side, I think. What do you think, chat? Should these be side by side or just like one on top of the other like they are right now? That looks kind of weird. Or should I have like some comments in between them? The second paragraph would go. Another thing I'm not very good at is design. I think actually what I need is, I think I need like a here's what it is that goes under the heading. And then I can talk about the RX path here. And then I can talk about the TX path and the design constraints of that here. I think that's probably the way to go. It'll kind of flow logically. I think some text between images is probably better. Yeah, I agree. I think that'll go pretty well. So Elysium was a radio. TX was a good friend of mine. RX never understood a thing I said, but LNA helped me drink my wine. Wait, why did I become the bullfrog in this metaphor? Oh, hello, cat. The cat has awoken. Everyone say hi to the cat. This is actually only one of the cats. Oh, you're so cute. He's such a good boy. I have very good cats. Say hi to Dub. I wonder if I can get him to purr into the microphone. Can you hear that? Oh, he's so cute. Oh, okay, buddy. Go about your business. The other one, by the way, is snoring in the chair next to me. He's out of frame, but okay, yeah, I think this is a good. All right, so let's talk about Elysium. Okay, so Elysium is a radio that I made at a company I started called Adamant Aerospace after I left Planetary Resources. I drove that company into the ground. If I had the money at the end or the knowledge at the beginning that I had, on the other sides, then I think I could have made it work because the CubeSat market was booming then. And, that was kind of the idea, was to make avionics for CubeSats. I had a really good understanding of the kinds of technical problems. I had a good understanding of why people felt the need to develop in-house solutions instead of buying off the shelf. And I thought that I could provide off-the-shelf solutions that were actually, workable. But I had no idea how to run a business, turns out. And by the time I figured out kind of how to run a business, I ran out of money. And also, some unrelated personal stuff happened, but that always happens. So, Anyway, Elysium is basically the only product from that business. It did go to space, though, so that's pretty cool. And I'm still really proud of it. It hit all of its design goals and it's a really good design. I'm really proud of it. Okay, Elysium, VHF, UHF receiver was the primary. Very cool. Any lessons to share about running a business? So, if you are leaving a technical job, also hello, hi Dithinas, Jiggly Girls, welcome. Thank you so much for stopping by. I really appreciate you stopping by and also saying hello. Okay, so if you are a technical person and you're leaving a technical role to start a business, you are doing that because you have a technical skill and you think that you should do it for yourself instead of for someone else, which is totally reasonable. But it is very easy to get stuck in a technical mindset. I spent so much time solving technical problems and coming up with creative technical possibilities, designs, product lines. I had these really cool solar panel plans that never went anywhere, that I did not spend the time that needed to be spent on things like sales and marketing and customer development. And what's really insidious is that I thought I was doing those things, right? I was going to conferences, I was talking to people, but that's not actually how that works, right? You go to conferences and you meet technical folks, mostly. You meet engineers. And I met some CEOs and some salespeople who kind of tried to be like, hey, you really need to go out and make some sales, and you really need to figure out who your customers are and what the size of your market is and what you actually need to charge. And I thought I was doing those things, but I really wasn't. And it's really easy to slide into the technical. Sales, marketing, blah. Yeah, I mean, I felt that way too, but sort of subconsciously, right? The thing is, we are exposed day to day to the scummiest kinds of sales and marketing, because the sales and marketing that isn't scummy doesn't need to be so in your face about it. Good salespeople are actually not scumbags, as hard as that might be to believe. Good salespeople are going out and they're saying, look, you have a business, you have business goals, let's figure out if my company and the products that we make can help you meet those goals. And if the answer is no, a good salesperson says, okay, maybe I know somebody who can do that. Or maybe we can't help you right now, but here's my card and call me back. And then they back off, right? Like good salespeople, you want to hear from. Like you're happy when your phone rings. Bad salespeople, not so much. Marketing is very similar, right? There is the kind of marketing that is, I'm going to buy 1,000,000 Facebook ads. And then there's the kind of marketing that, in a way, I'm doing marketing right now, right? I'm available for freelance work. If one of you wanted to hire me, this would be potentially a way that you would find out about me. But I'm also sharing, the knowledge and the experience that I have with the community. I'm also, engaging. I'm being a member of the community in all these different ways. That's that is marketing. It's not what you think of as marketing because, again, you're exposed to terrible marketing all the time. So I think that's honestly a big thing. If you can get involved in communities and then solve problems for those communities, that's how you're going to succeed at starting a business. You don't get extra points for playing on hard mode. You have this picture in your head that like you have to be doing something that's sufficiently impressive. You have to be like solving a quote unquote real problem. Not really, right? Like you have problems. You know how to solve problems for yourself. Oh, hey, DX. Thanks for stopping by. You have problems. You know how to solve problems for yourself. People who hire you, you have problems. You know how to solve problems for them. People who kind of want to come into your, like people who aspire to be in your career or whatever, those people have problems and you know how to solve problems for them. Sometimes those problems are, what is a coplanar waveguide? And why should I care? Sometimes those problems are, I don't have in-house expertise in RF and I need, this project has this RF thing and I need help with it. I guess what I'm saying is marketing and sales aren't the devil. It is easy to feel that way when you've had only bad experiences with them. I completely understand anyone who does feel that way. I've felt that way at times. I still feel that way at times, right? When the sales team at my current job comes in and says, oh, I promised the customer X. Sometimes I want to like rip my hair out or rip their hair out because we don't do X and we will never do X, or we won't do X for 6 months and you promised it in 6 weeks. But yeah, don't have to be the devil. Okay, how about that, right? You meet very bad salespeople. You meet occasionally good salespeople. It's just, it is really easy to, because of that distaste, undervalue those parts of the business, but they're critical to making a business case close. Anyway, I hope that was not too soapboxy. And you know what? If you heard that and you were like, yeah, whatever, you don't know what you're talking about, that's cool. I don't know everything. I've been through certain things, and they happened to me in a context, right? I'm a privileged white dude. I was, 24 at the time, or 25, whatever. These happened in a context. It was a very different world. We didn't have a coronavirus. And secondly, I have found that I can hear the same advice a dozen times, and it will only hit me when it's the right time, right? So if I just said a bunch of stuff and it didn't really feel like it meant anything to you, okay, that's fine. Just kind of like file it in the back of your head, and someday if you're like, boy, I really would like to trot out on my own and start a business, just kind of dust it off and look at it and see if it makes sense to you then. And if it doesn't, whatever. Again, I hope that wasn't too preachy. I do kind of have a tendency to get all soapboxy. Okay, I did not really manage to leave. Your take is very interesting and accurate. Posted your stream on Twitter. Hope this helps. Thanks, Destin. I appreciate your thoughts. Cheers. I'm glad. Spicy hot takes. I am happy to be called by some of the Arrow sales reps. They're actually working hard to make things work out and find parts and this is marketing. Good marketing. Yeah, exactly, right? It's good marketing. It's good sales. Um, and then I bet you have some sales reps that you're less happy to hear from. And it's like anything else. There are good folks, there are bad folks. You want to work with the good ones. Oh, that's another thing. You want to set up a business so that you can choose to only work with good clients. If you are in like a desperation mode, it's really easy to say yes to everything, but a lot of clients are not worth working for. And a lot of like jobs aren't worth taking, even if they are for good clients. If it's not a good fit, or if it's the money isn't there to where you need it to be, or whatever. You want to set up your business such that you are able to make those decisions with a clear head, and you're not forced by external pressures. Seems like Esden might have a few experiences with this. Yeah. So, I mean, you want to be set up in such a way that you can handle that. And if you can't get set up in that way, then maybe your business doesn't actually quite work, which can be a really hard thing to hear and to realize and to admit to yourself. This is, by the way, how I always feel when people are like, wham, wham, minimum wage is going up. Like, if you can't pay people enough money that they are not on food stamps, you don't have a business. That shouldn't have to be said, but for some reason, it's 2021 and it has to be said. That's an extreme example, obviously. Oh, and by the way, if I try to hire you, charge me more than $20 an hour, please. I keep like I don't want to like be Patrick McKenzie on you, but like way too many people. I'm like, hey, do you maybe want to work on something together? And they're like, yeah, sure, you can pay me dirt. And I'm like, no, I'm gonna pay you more than that, and please charge more. Just do. Sorry, I got distracted once again. So for new people, thanks for stopping by. I'm kind of just casually working on my portfolio website. You can see its current state at aweigel.com. It will not have any of this portfolio stuff because I haven't pushed it yet. But basically, I'm setting this up because I'm going to, I'm trying to get some more freelance work, and I think this will be a good showpiece. I'm also just answering questions about these projects, some of the my experiences, the things that have happened to me, things that whatever, technical, social, whatever it is interesting to you. Chime in with a question or a comment or whatever. I'm really enjoying talking to folks. Right, so, and in some sense, the only product of Adamant Aerospace. It is a VHF, or no, I already said that. It is designed specifically for the needs of small CubeSats in the 1U to 6U class. There was a night. Oh, I didn't notice. I actually did, but insomnia can go bite my bites. Oh boy, insomnia. I have sympathy. Few, not just me. DX, are you in the States? I mean, if you're comfortable saying. Oh no. Wait, how do I un-nightbot you? Oh no. Hang on. Timed out for 5 seconds. Okay, so hopefully you're back, and I'm just gonna go ahead and turn off Nightbot because nope. Spam protection. Disable. Okay, turned off. Sorry. Yeah, I don't know why that happened. I'm just gonna go ahead and turn off everything except blacklisted words. Anything with SMA connectors on it gets my attention. Oh, hey, MebX. I'm not really sure how to pronounce that, but welcome. I appreciate you stopping by. Yeah, so just a quick overview because I'm trying to write it down and failing, so saying it out loud will help with that too. So this is the Elysium radio, which I designed at Adamant Aerospace, which is the company that I ran into the ground. And it basically the design constraints here were this: small CubeSats, right, 1U, 6U, kind of that range, are often very power limited because they're small, and it means they only have so much area for solar panels. So the primary driving consideration here was power consumption. So the receiver side, which is down here, can support like sitting around waiting for a signal to arrive draws 25 milliwatts or less of power. And that was one of the main design goals. The other main design goal is that the transmit shouldn't break the power bank either. So the amplifier used is a Class C amplifier, which is fine because it's a frequency shift keying radio. So it's 50% efficient up to 5 watts RF. So that was another, major design goal. And then the third one was that it should be within reason tolerant against radiation damage. And the way that worked was, this is an MSP 430 that uses FRAM memory instead of SRAM and flash, and or FERAM if you prefer. And that stuff is really resistant to radiation damage. We actually stuck one of these in a medical accelerator, for nuclear medicine kind of thing, for cancer patients. We rented one out and we stuck one of these MSP 430s in it, and we hit it with a mega rad of radiation before it died. We actually killed the test laptop long before we killed the MSP, and the test laptop was 3 feet away. So they're pretty sturdy. So that's kind of the idea here, and it did meet all those design goals. Its performance was pretty good. This is an LNA that is a discrete LNA. It's powered by a bias T. How does FRAM work? I've never heard of it. So it's ferroelectric RAM, and it uses the ferroelectric effect of certain ceramics, which it's like ferromagnetic for magnets. There are these little domains of charge, and if they are unpolarized, then that's a 0. And then if you can polarize them with an electric field, and then that will read as a 1. Reads are destructive, so you have to refresh it every single time. But yeah, basically the same physics with hysteresis of ferrites, except that it's electric instead of magnetic, so it can switch a lot faster, and it can be it's a lot lower power as well. The real equivalent to core memory is MRAM, which is magnetic RAM, which literally is just core memory on a chip. And the difference, they're both very radiation tolerant because of the physics of how they work. But MRAM, I think mostly from marketing reasons, is dedicated a lot more to high speed, high power than it is to low speed, low power. The problem with FRAM is that it requires extra process steps, and also there seems to be some scaling limitations. It's hard to make it super duper tiny. I think these are on 140 nanometer process or something like that. It's pretty big for a chip process these days. So we haven't seen it take off the way that MRAM has with things like spin transfer torque MRAM, which is really more targeted at a DRAM replacement. Oh, and it's non-volatile, right? Even though it's RAM, it's non-volatile. So you remove power, just like flash, it'll persist. Thank you for all the info. This is fascinating. Oh, I'm glad that you're interested. It's pretty cool stuff, actually. I'm a big fan of FRAM and MRAM. Another place that you'll see it a lot is old video games that had battery-backed SRAM for save games. You can often get a drop-in replacement FRAM part, and then you don't have to worry about the battery running out. They also have 10 to the 4th endurance, or 10 to the negative 14th. whatever. They're very stable compared to like Flash, which has, you know, after a while the cell wears out. You can only have so many writes and reads and stuff. You can do like 1 times 10 to the 14th writes, I think is the number I'm trying to pull out of my head. So it lasts forever, unlike Flash, which Flash is one of those things that like almost doesn't actually work. And we just kind of like gaslight the electrons into thinking that it works with lots of error correcting coding. And FRAM is not like that. Yeah, I watched this channel that refurbishes pinballs. He drops the FRAM chips into all of them as preventative maintenance. Yeah, that's a really good idea. It makes total sense that there's SRAM in a pinball machine, but it never occurred to me until this moment. It works, but you don't want to know how it works on anything outside processor, Flash, or so. Because it's terrifying and will make you not want an SSD. Oh, man. I'm not sure how much... I guess I don't really have any particularly secret information. So the company that I work for, one of our main business lines is that we program flash memory, right? That's our whole thing. Data.io Corporation, if you want to look them up. They've been around for 50 years. But we deal with flash vendors really closely, and the things that they do, like we have PLC flash now, penta-level cell. Like the noise margin on something like that is like 4 electrons. It's crazy pants. Jeez. Consumer grade flash especially, it's like, whoa. Flash is so cool though. Like the physics of Flash are so interesting, and like the reason why we transitioned to TLC and 3D at the same time and all that, it's like really cool. Stochastic memory. Yeah, exactly. I mean, and don't think Flash is the only one, right? Like go look up firmware first DRAM error reporting. I think a lot of things like that in the world. I imagine at the very transistory level of the 14 nanometer and 7 nanometer processes, it's probably very similar. You know, that I remember when I learned or realized that like RAID 5 basically didn't work on sufficiently large hard drives because you would get a read failure while trying to re-image. SDRAM is in a similar vein. Yeah, exactly, right? Like, look up DDR4 error rates and then weep. Yeah, anyway, it's all built on a shifting quagmire, but somehow it all works out. So, what this means in terms of technical design constraints is that solar panel area is very limited, and thus power consumption tends to be the limiting factor on system performance. House of Cards. Never watched it. Aren't I hilarious? I mean, I don't know if the House of Cards is fair. There's a lot of really smart people who work on these things who are doing their level best every day to make sure that it, you know, works, and you can get useful results out of these imperfect technologies. I try really hard to focus on that aspect of it, like the incredible work that people are doing and how amazing it is that we can make these things at 7 nanometers, and less on how scary it all is, right? Like it's fun to kind of go on a rant on Twitch about, you know, flash memory, and I do fall into that trap obviously a lot, but I try to focus on the cool side of it. Established a power consumption target of 25 milliwatts for its receiver, an order of magnitude less than the next best in class, and an efficiency target of 50% at 5 watts for its transmitter. That all of this electronic stuff works is magic after all. Let's enjoy the magic of it and have fun with it. Yeah, absolutely. And like not just electronics either. Like everything is interesting. The world is fractally interesting. You are like, "Oh, how interesting can glass blowing be?" Like it seems really cool, but you know, it's ultimately it's an art thing, right? And then you look at it and it's like, "Oh, there's 1,000 different kinds of glass and you can heat them in 17 different kinds of furnace and, you know, add, you know, 15 different kinds of additives and the physics of it, and like everything is interesting in like a self-similar way. No matter how much you zoom into any topic, there's always like more cool stuff to learn. The world is great in a lot of ways. It's terrible in a lot of ways too, but in a lot of ways it's really great. And you can blow it with your lungs or a bicycle pump or or not at all, right? I mean, I guess I did say glass blowing, but like there's lots of glass working techniques that don't involve a blowpipe at all. What really made me weep was discovering just how bad the error rates are on and how much the ECC is relied upon for normal operation on Seagate Constellation drives are. Yeah, anything that's QLC, like a lot of the time you can look at, okay, what is the actual write endurance of this thing, and it's like 500 writes. It's like, oh boy. Yeah, I mean, it's true. At the end of the day, it's like, okay, they're doing this so that we can have this product at this price point. Oh, those are spinning rust. Okay, fair. You know the fly height of a hard drive platter is like 800 picometers now. In sealed helium drives, it's crazy. Those things are so complicated too. Which trades increased efficiency for increased nonlinearity. Everything is complicated, absolutely. The error rates on some of those are so bad that the counter for both seek errors and ECC errors wraps on a weekly basis. Wow, that does seem extreme. Which is why a frequency shift keying modulation was chosen. The Elysium receiver is based on a highly integrated price point optimization. Yeah, exactly. It's like it is terrible, and also consumers ultimately drive a lot of that terribleness. I don't know. It's tricky, but I guess at enterprise it's a little bit different. The Elysium receiver is based on a highly integrated RFIC from Semtech, which draws 3 milliamps in a receiver idle configuration. the trade-off for this low power draw is that the front end has a very high noise figure of nearly 6 dB, mostly due to how tightly coupled it is to the digital circuits. Okay, now really, see you later, everyone. Good night, Esden. Get some sleep. It's like almost 11. Actually, I should get some sleep pretty soon, too. How has it been 2 hours? Wow, this has been fun. Was crunchy inside. Oh, jeez. To overcome this high receiver noise factor, a discrete LNA was designed to... Wow, this has been fun. It has been. To bring the system noise figure down. Is it noise factor or noise figure that's in dB? I'm pretty sure it's noise figure. To a more acceptable value of less than 2 dB. The LNA is powered via a bias T, which is a load option on the main Elysium board. Noise figure, yeah, I thought so. Factor is unitless, that's what I thought. It's been a long time since I've done RF stuff. I miss it. If you want to hire me to do RF stuff, please do. It's been a really long time since I've done any, and I would really enjoy to do some. I've been thinking about playing around with the ESP32, the RISC-V one. I think that would be a lot of fun. The LNA is powered via bias T, which is load option on the main Elysium board. And is efficient enough that even with it enabled, the total system power draw remains under the 25 milliwatt target in the receive idle mode. I definitely go with the ESP32S2 in that case. Yeah, I really like that design. The new RISC-V one also looks cool. I haven't dug into it super well. Basically, I want to be able to write Rust. And I don't think there's an Extensa. I mean, there's like an Extensa fork, I think, but I don't think it's really mainline. But then again, I don't actually remember if RISC-V is mainline either. I think it is. Down converter. Okay. Although many CubeSats operate in the VHF and UHF bands, it is increasingly common to see the S-band or X-band as well. To enable the Elysium to serve customers with a an uplink allocation in the S-band, a frequency down converter, LNB. Okay, let's just use that whole. A low noise block converter, LNB, was designed to convert from the 2100 megahertz band to the 135 megahertz VHF band. The VHF band is used as an intermediate frequency. The total system power consumption in this configuration is less than 100 milliwatts in the receiver mode, which is again an order of magnitude better than the next best in class, or was at the time I designed it. Cascaded low noise amplifiers. I should probably define LNA here, huh? Low noise amplifier, LNA. Once again, I just want to say thanks everybody for stopping by. I really appreciate it. If you haven't spoken up in the chat, feel free to do so. Obviously, you don't feel pressured to, but if you want to say hi, if you have any questions, if there's anything that you want to hear me talk more about, as I'm kind of going through this portfolio, by all means, please chime in. I'd be happy to talk to you about it. We're probably coming close to the end of the stream. We probably got like maybe 30 minutes more. So if you've been kind of thinking, oh, well, I want to chime in, but I'm not sure, I would encourage you to do so. And if not, thanks for stopping by. It means a lot. Like, comment, subscribe. Wait, no, wrong platform. Oh, speaking of, actually, my dumb joke, all of these streams get uploaded to the my YouTube channel, which is just A Weigel, or it's actually Andrew Weigel on YouTube, because A Weigel was taken inexplicably after the 24-hour hold imposed by the Twitch affiliate program. So if you want to watch an older stream or rewatch this for some reason, you can do that at my YouTube channel. Anything else? No, I don't think so. Do you get more watts per meter squared from a solar cell on orbit than at the Earth's surface? Yes, you do. So there's is it AM? Is it the like atmosphere model for how much illumination a solar panel gets? And AM1 is basically Earth's surface, and then AM0 is space. So you do get more watts per meter squared. It's not a ton more because the atmosphere is relatively transparent at solar cell wavelengths, but you do get more. There's a lot of really cool, whoa, what just happened? There's a lot of really cool stuff that happens in solar cells for space, where they use like 5 junctions, because the weight trade-off and the volume trade-off is such that it actually makes sense to use these really cool advanced solar panel technologies. But then those turn out to be really expensive. CubeSats are often tried to be built on the cheap. So I had this plan to use these gallium arsenide thin film cells, which have good radiation characteristics and are much cheaper and have good efficiency, as like a budget option. That never materialized because I never found anyone to pay for it, because, as I said before, I didn't do nearly enough marketing and customer development. That was when I was at Adamant Aerospace, which is the company that I started after I left Planetary Resources. Keep the system noise figure under 2 dB. I think that's basically all the interesting stuff about the Elysium. Write some more and medium platform descriptors. The Elysium VHF UHF transceiver was the primary. Yeah, okay. I just wrote this. I don't need to read it again. I'm still pretty proud of that design. I've said that a bunch, but whatever. Whew, boy. I've been talking a lot for the last 2 hours. Actually, you know what? I'm going to take a break real quick. I'm going to grab some water. I'll be back in, I don't know, like 2 minutes. Okay, I'm back. Did you all enjoy watching the Cursed Kong loop? If you haven't been following me for a while, that is the result of an earlier set of streams, which was an attempt to develop a an NES emulator in 2 weeks. That is as far as I got, but I think it makes a pretty good like a tracked loop. If you want to catch some of those streams, I kind of talk through the design. I talk through, I did it in Rust, and I talk about what the challenges were of doing that and the design and blah blah blah. You can catch all that on my YouTube channel if you're at all interested. It was a pretty fun project. I would like to get back to doing emulator stuff again sometime. You know how it is. Infinite projects. I think I want to break these pictures up. Do I? Or maybe I just want one. I think I just want one. I think I just want this one because it's more cool. I've been watching while working on porting OpenVisla from OMeGen to NMeGen compat. What is OpenVisla? I'm not familiar with that. It sounds like some sort of demo scene kind of thing. I also have to figure out maybe how to make all of these pictures align center. I'm sure that's easy to do. Whatever. Okay. This design is an NFET controller for new eGANFET devices. GANFET devices are excellent choices for space applications because they have very low on resistance and are very tolerant of most radiation effects. However, OpenVisla is a USB analyzer. Am I right in saying this is the correct translation for this OMeGen instance parameter to NMeGen? What to look at? Yes. Yes, that is correct. I_clock in. For those of you who don't know what we're talking about, NMeGen and MeGen are both new HDL languages, both written by WhiteQuark mostly. I contribute occasionally to NMeGen, and so on the Digital Design Discord server, which you should all join because it's great, I talk about NMeGen pretty regularly. Right, so however, they are only recently available in enhancement rather than depletion modes, and they are still only available as NFETs rather than PFETs. This design is intended for use as a high side power switch based on GANFETs, which, you know what, I'm going to stick this under Adamant as well, but Mr. Freeze is a high side power switch. It is designed entirely in discrete BJT transistors. Probably width is better than in here, because BJT transistors are less likely to fail catastrophically when exposed to most forms of radiation than FETs, rather than a destructive event like a gate rupture. BJTs will instead see a decrease in their gain, but will otherwise continue to function up to a point. I actually have in my resume, I think, a thing about Glasgow, so I'm probably going to copy that and then add some comments about what I actually did. Right, okay. By the way, we got like 40 hours left on the Glasgow crowd supply campaign. If you're not familiar with it, it's basically a multi-tool for electronics. It's designed to replace or really subsume your FTDI cables, your logic analyzer, your various programming pods, etc., etc. I would highly recommend you check it out. It's a pretty cool project. My name may still be on the board, but I really have had almost nothing to do with the recent versions of the design. I don't get any money if they sell more, so this is not really a bias review in that way, but I would recommend you check it out. It's a really cool project, and a lot of people put a lot of work into it. Is a multi-tool for digital electronics intended to replace the proliferation of programmers, serial cables, and logic analyzers, which clutter many designers' desks. I was deeply involved in the first 2 revisions of the PCB before I left the project is not really accurate. I mostly fell off the face of the world. Alright, while Marcan 42, I think that's how they're credited on here. Yep. Was the primary designer of the Rev C. My contributions to the Rev B were primarily around the level shifters, which were originally auto direction sensing. So my understanding, Esden's not here, is that Esden has been primarily involved on the production side, right? Because 1BitSquared is doing the actual production. White Quark did most of the software. Marcan, at least for the first Rev, did most of the PCB stuff. I don't know. I'm going by the PCB, right? And it says manufactured by 1BitSquared, but it says that the designers are White Quark, myself, and Marcan. Still kind of surprised they left my name on it. Don't really think I deserve it, but I appreciate it. It's very nice of them. He did do the design for the current reset circuit and a lot of DFM improvements for FC2. Okay, yeah, that makes sense. Alright, I'll add a note about. And as many others contributed to the production Rev C2. Thanks, DX. I appreciate that. But which were transitioned to direction controlled after we encountered insurmountable difficulties and the ADC and DAC designs used to match the interface ports with the device under tests voltage. Glasgow recently completed a successful crowdfunding campaign. Set paste. Set no paste. And manufactured is now factored primarily by 1 bit squared. I really have no idea how to summarize this enormous project, but whatever. This is good enough. I will just talk to people. Alright, and then is currently bulking at OpenVisla, manually instantiating Spartan 6 buff Gs in its clocking module. That seems like a good idea. By and large. I'm clearly running low on battery. I can feel myself buffering anytime I have to switch contexts. Alright, let's write a quick Runelord blurb, because I still don't want to talk about it too much, but an active project to develop a Nintendo 64 flash cart, which is released as open source hardware and driven entirely by open source software. Okay, and I think that's all I'm going to say about that. HTML center image. I'm pretty sure you're supposed to do this in CSS these days. Class center. Okay. Well, I still have it in paste mode. That's why. The problem with changing away from escape, which who's going to reach that far every time, is that when you do set paste mode, it goes back to being escape, and then if you don't set it back, then you, in my case, leave JK after every line, because that's how I get out of insert mode normally. Alright, let's see how this looks. I do want to drop half of that one, but it's fine for now. Yeah, okay. I wonder how big this page is in terms of size. Whoop. Excuse me. Okay. No way is this 9.81 kilobytes. That must not include... Ah, alright, whatever. That Runelord PCB looks mighty pretty. Thank you. Yeah, the black really honestly covers a multitude of sins. Like you can see how kind of janky the bus routing is and stuff if you really zoom in and look at it, but it does look really nice. I like it a lot. PCBWay did a really good job on this one. clearly entering a low power state. All right, so I think this is good. I'm going to go ahead and push. What is in public? What is that supposed to be? Is that where it's hosting it? I bet that's where it's hosting it. Let me go ahead and kill it. Yeah, okay, good. And then we don't talk about the jank here. No, that's the whole point. I want to talk about the jank. I want to tell everybody about all the terrible mistakes that I've made. This is my new, like, crusade. I should probably be worried about the fact that I have a new crusade. Is, like, giving people permission to be imperfect, especially in the context of PCBs. I always see people who are like, oh, I need to get the zero inductance via, like, people are trying to, like, hyper optimize, and it's like, it just does not matter most of the time. What you really want to focus on learning is figuring out when it matters and then knowing the right amount of effort to expend on stuff, but it so often it's just not that important. Oh, I add commit. Okay, that's gonna make a lot of sense. All right, and then we will push 80-20 rule. Exactly, and like, you have to know what's 80 and what's 20, and you have to know when you actually need to push into that 20, which does happen sometimes, but you want to design your projects such that, like, it's not every time and it's not everywhere in the project. Are you working on something right now, Dub? What's your new jam? I guess you're in school, so you probably have, like, projects and stuff. Git is yelling at me for pushing giant files. Yeah, okay, that's fair. I probably didn't need to push the uncompressed TIFFs to my GitHub, but if I pull up my Netlify account on stream, is it going to be like, here's your credit card number? Maybe I'll just do it off to the side. I really need to join the 1B2 Discord. Are you building for me, friendo? You are building for me. Did you deploy? It says you deployed. Did you deploy? Hey, you deployed. Sweet. Alright, if everyone in chat could just... Wow. Total frog in the throat. If everyone in chat could just, like, click on that real quick and let me know if it's, like, horrendously slow to load, because these are some pretty big images. They're not that bad, but I think they're, like, a couple hundred kilobytes each, but it's still pretty large. Just let me know if it's, like, really egregious, and I will change it later. Looks fine to me, but we have gigabit. Bit of a spike on my network connection, but not nearly as bad as many corporate sites. Okay. In that case, I'm going to call it good for now, and then I might... What I really want to do is paginate it so that you only get one project per page. But I don't really want to try to figure out, like, from scratch how to do that in Zola while also on stream. Not that there's anything wrong with that, it just wouldn't be that interesting. Load's fine for me. Hey, K. Beckman. Thanks for stopping by. Are you the K. Beckman that I used to work with at Berkeley? What was I doing? Oh yeah, so I have these on the smalls, but whatever. Yeah, I want to like paginate it, and then I can have even higher quality pictures, but only one at a time, and then it won't be so bad. But I'll do that later. I just don't think it would be that interesting to watch me do it. Okay, all of my 10 viewers, I'm getting ready to wrap on the stream. If you have any questions or anything that you want to like ask about or tell me or whatever, this is your last chance. It's alright, 5 megabytes. You can put a list with thumbnails and they click them to see higher quality picture. Yeah, that's what I want to do. Well, I want to paginate it and then I want to put the RAWs actually up because these are really nice pictures. And I want to let people get at the full experience if they want it, but I'll get around to it. Yeah, so if you have anything else you want to say, anything else you want to tell me, any questions or whatever, now's your last chance. I really appreciate you all coming by. It means a lot that you take time out of your day to hang out with me. I hope that you enjoyed the stream. I hope that you'll consider, hitting the follow. A subscription even would be incredible. I certainly don't expect any of that. Yeah, RAW is good if you click. Yeah, exactly. I certainly wouldn't serve 50 megabyte RAWs to people's poor internet connections. Yeah, so I really appreciate you coming by. It really means a lot. If you want to see any of the earlier streams or like you missed the beginning of this one, go check out my YouTube channel. It's Andrew Weigel at YouTube. And yeah, I'm hoping to be back next weekend with something interesting. And I hope that you'll join me at that time. So thanks. Have a good night, everyone, or a good day, depending on where you might be in the world.